All right, great. Hey, listen, welcome back. We have Marcus with us, Celeste, and Max. All right, now today we're going to go ahead and go into, let me go ahead and share this screen, which is going to be, okay, we're going to actually going to be looking, oh, here it is. All right, so today we're going to actually cover surface areas of prisms and of cylinders. Okay, now we are going to combine something that we learned before to something new. So with that, let's start with Celeste. Celeste, why don't you go ahead and read this first vocabulary term? The one that says altitude of a prism or cylinder.
Okay. Altitude of a prism or cylinder. A perpendicular segment that joins the two planes of the prism or cylinder.
Okay. So go ahead and that's the blank.
Basis.
Yeah, the two bases. Okay. So that's, and the reason why that's so important is that altitude is this word right here. Let me go ahead and undo. Okay. And let me do this. Let me take this off and instead just highlight with, okay. When we talk about altitude, it's very important to be able to discover it. So altitude is going to be a line that kind of goes from base to base. Same thing from here to here. Okay, that's going to be kind of like what you discover with altitude. All right, good. Maximus, go ahead and read height.
The length of the altitude.
Yeah, good. So the length of the altitude would be the height. So they kind of go interchangeably. Marcus, go ahead and read lateral faces or lateral face.
Lateral faces. The faces that are not the blank of a prism or pyramid.
Okay, so that are not, so
base.
so anything that's not a base is considered to be a face. All right, now Celeste, go ahead and read oblique cylinder.
A cylinder where the segment joining the two centers of the base is not perpendicular.
Okay, so oblique just means that it's not the same. So you see how we have this space here and this space? You see how they're not perpendicular? And really what is happening is that I'm able to guarantee that the line that I make from here to here is not 90 degrees in regards to this part when you look at the base. So that's what's called oblique. So now the biggest ramification that we have as a result of this is you're going to discover the height is going to be sometimes off. Notice how the height's over there between the bases? Mm-hmm. Remember, to find the height, you need to find something perpendicular. So that's the biggest thing that happens. So you have to do maybe sometimes some extra work in order to solve these. Now let's go ahead and scroll down and have Maximus go ahead and read oblique prism.
The prism where the segment joining the two centers of the base is blank perpendicular.
So similar to on top, okay, they're not going to be, the height is going to be somewhere different. You're guaranteed that when they're oblique. All right, Marcus, go ahead and read right cylinder.
Right cylinder. A cylinder where the segment joining the two centers of a base is blank perpendicular.
Yeah, so for this, in this case, you're going to discover that the height and the altitude are going to be the same as a result of that. So it's kind of easy to discover that solution. Okay, good. Now let's move on to Celeste. Read the next. Go ahead and read right prism.
Okay, right prism. A prism where the segment joining the two centers of the bases is perpendicular. No.
Yeah, actually it is perpendicular. You're right. Now, remember, how do you know the bases? Just quick review. How do you know the bases of a prism? Does anybody remember any of you kids?
The faces, right?
No, the bases. Yeah.
It's the two sides that are the same and parallel to each other.
Exactly, yeah. They're both congruent and parallel. So actually, let me, instead of writing the word, let's write the symbol. Congruent and parallel. So that's the reason why you see these red lines. Both of these are congruent and parallel. Those two are congruent and parallel. So that's how you know you have bases. All right, let's go ahead and Maximus, go ahead and read lateral area.
An area of all the lateral faces.
Great. Marcus, go ahead and read total surface area.
Area of all the lateral faces and the bases.
Okay, good. So sometimes it's important to know just lateral area because lateral area just gives you just want to know what goes around it. And sometimes you have to know how to do everything, this is the total, where one of them just goes around. And there's a couple applications that have that into use. All right, now let's go ahead and have Celeste. Why don't you go ahead and read the area for lateral area of, or go ahead and read this definition right here of lateral area.
Okay, the lateral area of a right prism is the product of the perimeter of the base and the height of the prism.
All right, good. So very easily, just to put it, if you find the perimeter, so, and let me change this, okay? Because in this case, the thing that we're trying to achieve is that just these little 4 areas, okay? If you can find the perimeter, which means you're basically looking for like these 4 values, okay? And then you multiply with the height, then you go ahead and get the total surface area. Does it make sense? Because then you're getting the height is consistent with all of it. So as long as you find the perimeter, you multiply with the height, you will get a total amount. So as a net, think about it like this. Okay. So as a net, this right here, from here to here, this is like the perimeter. And then this is a height. So notice how that's the reason why you get the lateral. Okay, because if I took all that apart, this right here is basically a description that I'll get these 4 places as a result. All right, good. Now, so Maximus, go ahead and read the next one, total surface area.
The total surface area of a right prism is the sum of lateral area and the areas of the 2 bases.
All right, good. So it makes sense. So the only thing we're adding in from the last problem is now we're also going to find the area of the 2 bases. But since those are different, that's the reason why it's to be added in. Okay, does it make sense? Okay, good. Marcus, go ahead and read the lateral area of a right cylinder.
The lateral area of a right cylinder is the product of the circumference of the base and the height of the cylinder.
Yeah. So one thing that I'm able to guarantee you is this, is that what formula does this give me? Oops. Let me go ahead and kind of redo that. What am I guaranteed with?
Circle.
Yeah. Well, that gives you the circumference of the circle, doesn't it?
Circumference, yeah.
Yeah, right? So once you know the circumference, like if you have a circumference of a circle, same thing. Like if I was going to go ahead and make a net out of this, if I put it out, it would actually make a square. And this is a circumference, which is 2 pi r, right? And the only thing I need to do is multiply with the height, and then I'll get the area of this. And we're only talking about lateral. Okay, does it make sense to everybody?
Yeah.
Okay, good. Okay, now let's go ahead and Celeste, go ahead and read total surface area.
Okay. The total surface area of a right cylinder is the sum of the lateral area and the areas of the 2 bases.
Yeah, so basically all we're going to do now, and the reason why there's 2 written on here is because we're given the benefit that the area of a circle is pi r squared, right? So since we have 2 of them, then we're just going to put 2 pi r squared. So on some of these, we just have to go about and find some of these values and then just use the formula. And you have the benefit, you could do it either way. So if some people are more hands-on, you could go ahead and just do it like more hands-on. And others could do it the way you feel safest. Now, Max, go ahead and read example 1, the directions.
Use formulas to find the lateral area and surface area of each prism. Round your answer to the nearest tenth.
All right, so they want you to find lateral area and total surface area. So they want 2 things. Okay, so they want lateral and then total surface. Now, in this case, you could find lateral area. Like in this one, you find the lateral area and then you just add the 2. To find surface, you add the 2 bases. But Maximus leaves is, how would I solve this one?
for number A? I mean, letter A?
Yeah, for letter A.
So we gotta find the, what's the
Yeah.
formula again?
Well, we're gonna do it with lateral. Now remember with lateral, it
Base
was
times
the,
height or
well,
something?
no, it was perimeter. Remember the area, the lateral for a prism was perimeter times height, lateral area, right? So find the perimeter. How much is the perimeter?
So we do 10 times 4.
No,
What?
actually, remember you have to find the perimeter of the base.
Wait, Daddy,
Oh,
I know
Perimeter of
That's
the
the
base.
area. Wait, 4, 4, 4, 4.
Yeah.
So 10.
So the
Wait, that's
perimeter
10.
is 16, right?
Yeah, 16 and then 10, 20, 30, 40.
And okay, so now that's the base, but so what would you do from here now that you know the perimeter? So what's the lateral surface area on this one?
So 16 times 10?
Yeah. So you're guaranteed that this is 160 feet squared, right? Okay.
Daddy.
Now, if you wanted to, oh, go ahead, Celeste. What were you gonna say?
So I knew the answer to this because in my class we would do volume about this. We would do what's the area for the base, and then we would do that times height.
Well, I know, but remember, volume and surface area are very different. So just got to keep that in mind. But the good thing is that at least you're able to discover that remember when you do volume on some of these that we're going to get into next units, is that you would do length times width times height. But in this case, we actually had to find the perimeter. So that's the reason we added the 4, got the 16, and then afterwards multiply with the 10. Now, Marcus, what will we do in order just to make this total surface area?
It'd be base times height.
Not so much. Remember, you have to find the area of each of the bases. So you see from this 160 that we came up with already?
Yeah.
Okay.
So,
We're gonna-
so it'd be
Yes,
160 times 2 base.
yeah.
I mean,
So we're gonna
plus base.
Yeah, so we're gonna add 16 and 16, right?
Mhm.
So as a result, it's not on here. Oh, it's over here. So there's our formula. We did what we said, and we also came up with lateral, right? And then to get the total, we're gonna add the 2 bases to it. So basically the 160 times the 2 times 16, as you were saying, and we get the 192.
32.
All right, good. Okay, now let's go ahead and now have Celeste. Why don't you go ahead and solve the next one? How will we do the next one?
Well, okay. So the triangle at the bottom is 3 inches, or is that for the 4 inches?
Well, this is what happens. Now, Marcus, can you maybe assist, or Marcus or Max, what is happening in here? Like, what are they trying to do? And
Find the
specifically,
area.
why do they have an X here?
Lateral area.
The X is because, remember, we have to find the perimeter of the base, right? So here's my base. Now, I know 2 of the values. Now, we have the benefit that we could use, I think that's what's over here. We use Pythagorean theorem. So you see the a squared plus b squared equal to c squared?
Oh, so many equations. Yeah.
Yeah. So that's what we're going to use in order to get this amount. So as a result, we'll know that x is 5. Okay. Now, if x is 5, then we'll get this amount that then you add all those together. So you'll get the perimeter. It's going to be 3 plus 4 plus 5. So we'll get 12. And then, okay. And then we'll know that now this is the other thing. The height. The height is going to be, in this
10.
case, just 10. Because remember, this is the height right here, the 10. And let me highlight that so everybody can see it. Highlight is 10. And then as a result, we'll get 120 inches squared. All right, good. Okay, so now let's, Celeste, what will we do in order for us to get the, or actually Maximus, what would I do in order to get the total surface area?
You do
Plus 5 is
perimeter. It's like the other one, right?
Well,
Perimeter
yeah, well, in this case, we just have to add the 2 bases,
base.
right?
Mhm,
So
on top.
what is the area of each of these bases?
it's 24.
So it's 12. So 12 times 2 is 24.
Well,
Yes,
remember, this is a triangle, right? So you got to keep, now this is where it becomes important that you use the right formula for the basis. Because remember, being a triangle, you're also going to apply the half.
half.
Yeah, you're going to apply the half. So as a result, in this case, you'll get 6. So we're going to have 2 6s. So in this case, it'll be 2 times 6. So we'll get 132.
Okay.
Okay, good. All right, so in this case, that's how you do that problem. Now let's go ahead and go on to the next one. Why don't you go ahead and go with your sister? Or did it get logged off completely?
Yeah.
All right. Yeah, go ahead and go with Celeste. So you and Celeste. So Celeste, you're gonna be trading the mic with Marcus when they get up there.
Okay.
Okay. So, all right. Now let's do the next one. And let me go ahead and let's start with this. Okay. Max, go ahead and classify. What kind of prism is this?
A hexagon.
Pentagonal. Remember, hexagon means 6. This one has 5 sides, so it'll be pentagonal. All right,
Okay.
good.
Yeah.
Okay, Marcus, go ahead and read the directions for B.
Can read.
B?
Yeah, for B.
Where's B?
Right over
Right
there.
here. Right here where it says the basis.
The bases are regular pentagons. Find the lateral area of the prism.
Okay, good. So how will we do this?
Since we're finding the lateral area, we would find the perimeter and times it by height.
Good.
So
So let's go ahead and find the perimeter. Lead me through it.
it would just be 5 times 5 because there's 5 sides. So 25 times 11 is what, 275?
275, you got it right on. Great, Marcus. Okay, now go ahead and give the phone to Celeste. Celeste is going to read the next one.
Okay.
Okay, Celeste, so what's the area of each of these bases? No, if the area of each base is 43, find the sum of their areas.
Okay. So if the base is 43, the side wouldn't it be 43 plus 43
What?
times 3?
Yeah.
Stop cheating.
Well, in this case, this is what you'll have. I think Celeste was looking for you for help. Now, so we're going to multiply it by 2 to find the area of each one to add them together. So we'll cover those 2 bases. So we'll get 86. And to find the total surface area, Maximus, what will we do?
I can't see that one.
You just got to put it all together. Remember, surface area total of this pentagonal prism is the lateral. Lateral is this part, which we found out what it was. Marcus went through that part. And the other one is the 2 bases, which we know that is. So here's the green, look, and let me go to the yellow. Yellow's over here. You see the 275?
So green, 86. But what's the perimeter and the height? I don't know.
We did that already. We discovered that.
When?
So 275 over here in yellow. And we go back and we put that in yellow too. And then we did the green, which was this part, 243, which is 86. And we just add it all together and you get the total. Remember, we're just adding up components.
This is going too fast. But
Well,
okay.
well, we could slow down, but we're just going ahead and adding up components.
Now
All
you
right.
have
Okay, so now let's get, so let's put Marcus back on. Okay, Marcus, go ahead and lead me to solving example 3. Start with the directions.
Okay. Find the surface area.
All right, good. So in this case, what am I going to do?
I'm going to find the surface area of this cube.
Okay, good. So how would I do that?
We'd have to find one base and times it by 6, right? So the area, or no.
Now remember, we'll still use the formula. So perimeter is 4 times 7, right?
Yeah.
Okay, so we know it's 28. And then we'll do the base is 7 times 7, which is 49. And then we'll put it all together. So we'll have 28 times 7 times 2 times 49. Okay, so as a result, my total amount is 294. Now, you could have also broke this down some more. You know, like if you wanted to just define lateral, before you do it, instead of putting everything all together at once, you could go ahead and done perimeter, which you knew was 49 times 7. And then you would have gotten that component of it. And then afterwards, you could go ahead and just add the two bases, 49 and the 49. Okay. All right, good. Okay, now let's go ahead and have Celeste, go ahead and read example 4.
Okay. Find the lateral area of each cylinder to the nearest tenth.
Now, this is very important. You see how it says leave in terms of pi? So Celeste, do you know what to do there?
No, not really.
Okay, it means that in this case, you're gonna leave things, because since some of our equations are gonna have like 2 pi r or pi r squared, okay, we're gonna leave the pi. You're not gonna touch it. You're gonna do all the math around it. Make sense? That's how you leave it in terms of pi, because since pi is irrational, sometimes you get the biggest benefit of the best perfect solution by leaving the way it is. All right, so now do this, let's say, lead me through. Wait, is Marcus there?
Yes.
Marcus, look at the problem and lead me through solving A.
Okay.
Yeah, how will we do this next one?
Lateral area of each cylinder.
Okay.
Okay. So the lateral area is just 2 pi r times height, right?
Yeah, good. 2 pi r times height. So how much would that be?
So
Again,
r is 2, height is
Yeah.
10. So yeah, you plug that in. So
Okay.
that would be 40 pi.
Good. Yeah, 40 pi, right? Good. And then what do we do to find the total?
The total, you would add 40 pi plus 2 pi r squared.
Yeah, so as a result, we know that this part is 40 pi, right?
Mhm.
No more dealing there. But now we're going to focus on adding the pi r squared, 2 pi r squared, right? Because there's two bases. All right, so from there, we'll go ahead and then plug-in's going to look like that. Since you know the radius is 2, we'll get 48 pi. So this is going to be, yeah, this will be 48 pi because this is 4 times 8. So you add, this basically becomes 8 pi. And since we have 40 pi's over there, even in terms of pi, we get 48 pi. All right, good. All right, Maximus, lead us through solving B.
Okay, so we get 2 pi, then we replace the r with 7.5 and the height with 32.
Good, 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 yeah.
Oh my gosh, okay.
No, don't worry. I'll give you the math. It's 150 pi. And then what do we do next?
Wait, you plus the pi with radius?
Well, you add the two bases. Because
Oh.
remember, you found this, and let me deal with the highlighter. This 150 pi was just the sides. This part right here, the 2 pi r is going to be the bases, the ones in yellow.
Cool.
Okay.
Okay.
So, what's the last thing you're going to do is just take that same r, the 7.5 you found out, and plug it in, and as a result, you'll get you'll get 262.5 pi.
Okay.
All right, good. Now I think that there's one other one we're going to do, or let's see how many more there's going to be. And this is our last example. Okay, good. Celeste, go ahead and read this one.
Okay. An artist creates a right prism whose bases are regular decagons. He wants to paint the lateral area of the prism. 1 can of paint can cover 32 feet. How many cans of paint must he buy if the height of the prism is 11 feet and the length of each side of the decagon is 2.4 feet?
All right, good. So what are we looking for?
Lateral surface area.
Yeah, lateral. Good. Okay, so in order to do that, what must I do, Marcus?
You need to find the perimeter of the bases and then times that by the height.
Okay, so lead me through it. How would I find the perimeter of the bases?
So it's a decagon, that means it has 10 sides, and each side is 2.4 feet. So that's 10 times 2.4, which is 240.
Well,
Then 200, no?
No,
24.
because it's 2.4. You were close on. It was a decimal of 3 r. 2.4 times 10 means you get 24.
Yeah, sorry.
No worries. And then you multiply with the height, right?
Yeah, which is 11.
Okay. Now, once you get to 264, what do we do? Because this is the total surface area.
Oh, after we get 264, we divide that by 32.
Oh, good. Yeah, exactly right. So you must buy. Now, why is it that you must buy 9 cans of paint?
Because you always round up.
What would happen if you bought 8?
Well, you would have 1/4 of it missing.
Missing, exactly. You'll have a little small piece not going through, right? All right, excellent. Now let's see if there's any more. No, that was it, kids. All right. Hey, so thank you so much, Celeste, Marcus, and Max. Thank you, everybody at home watching. Hope this helps, and tune in for next time.
Next one.